in high school and uni was really interested in maths, science, physics, and I liked the techniques, the problem solving elements of that. Out of uni, wasn't sure which area to go into, but I saw data analysis. That was a role that was becoming bigger as companies got more and more data and need to utilize that to get more advantage, competitive advantage. And it actually used a lot of the techniques, algorithms and maths that I was really interested in. In time, that evolved into using more statistics, and machine learning became bigger and bigger, and out of that the field of data science, and that could answer questions that couldn't be answered before, trying to predict, for example, which customers most likely to churn, trying to predict the sentiment of customer reviews. It needed compute, needed algorithms, and because of the power of that, it got bigger. More focus on those areas, and the field has only really expanded since then, the last 15 years or so. You've seen that recently in the last few years with Gen AI and LLMs. That again can answer questions that couldn't be answered before by traditional data science, machine learning approaches, and be interesting to see where that goes in the future as well. So really keen to follow along, see how it evolves, and it's a really exciting area and will continue to be. Generally it's more challenging, I think. The field's called NLP, natural language processing. In traditional data it tends to be more tabular, so it might be things like gender, age, location data, the kind of products that a customer owns there as well, and that can be used to do things like which customer is most likely to buy product A, B or C, to do recommendations and so on. With natural language processing it gets more complicated because the data doesn't fit well into a tabular format naturally. It needs quite a lot of transformation. How do you convert language into numbers is the challenge there as well. So that's primarily the main goal of the field, is to transform the language into numbers, so then you can apply quite similar techniques to language that you could for the tabular data. So it really has a whole other component, which is that conversion space there as well, which is the same for things like sentiment analysis, classification. Again, that's harder because you're trying to predict whether someone liked or disliked something there as well, as opposed to whether someone churned or didn't churn, which is essentially just a 1 or a 0, and based on a bunch of attributes that you know about the customer. It's more challenging, a lot more different techniques there as well, and it's also an area that's had a lot of focus in the last decade or so. Particularly you've seen the outcomes of that, I think, with large language models, also deep learning classifications, which is something that we use at Call Journey here as well to predict things like what's the utterance inside a call dissection. Are people talking about whether it's the greeting, the closing, information retrieval, which parts of the call are taking the most time, which parts can be automated there as well. And that requires several different techniques, which are a bit more evolved than what's used for, I guess, the standard tabular data there as well. There's a range of applications. They kind of vary from ones that are very useful, widespread, and things that haven't been able to be done before. But quite commonly used. For instance, call summaries. Call summaries, you have a call and it's transcribed into text, and you want a concise summary of that. That has a lot of value. You might have a history of calls from a particular customer, and you want to know the previous conversations and how they went and what it was about in order to focus the next conversation. Traditionally, that was very hard to do in an automated fashion. You could try to do it from keywords, you could try to do it a rule-based approach, but it was never particularly successful. With an LLM, straight away you can ask it a summary of this call and give it some rules and constraints in the prompt, and that summary can be really valuable for a whole range of contexts. We can also look at more sophisticated approaches there as well to try and extract very key elements of the call. We might want to understand exactly why, what's the number one reason, what was the purpose, the intent of the person calling. We might need to know why did they complain, what was their reason for being dissatisfied. To do that, again, without an LLM, you can try with rules, you can try with context-based words there as well, but the success rate is much less than directly from Gen AI. So it's really that Q&A, I think, is the main value for the prompting and the LLM there as well. I mean, it's definitely important. I think there's lots to take account of and take care of when using LLMs. PII, personal information, that can be injected into a prompt. For instance, a full call can be put in there and that has the name of that person, it has the name of their relatives. Potentially that information can then be passed back into the LLM itself for future training. That's why we're really careful with PII redaction, approaches to actually avoid any sensitive PII information such as names, addresses, locations, values, employees, and so on. And then that way, it's really not useful information either. When you're talking about a call center, the name itself is not what you want. You want the trends, the important issues, how to resolve them quicker, how to answer the problems of customers better. So to avoid that straight away is a good foundation there, I think. The other one that I've seen is around hallucinations or inaccuracies. So an LLM, it's a stochastic approach. That means there's a degree of randomness in the answer. It doesn't give the most highly probable answer. Even if it did, sometimes it could hallucinate, but it doesn't. And so, 99 out of 100, it's pretty good. But what if there's that one time where it gives either a wrong answer, a nonsensical answer, and you're trusting that for very important decision making, that one time 1% can be wrong. That's where it needs human intervention or approaches to actually account for that. And so we do look at different techniques to try to identify when it's wrong and how to actually correct that. One of the ways you can correct it is actually rerun it. So you ask the same question twice, you will get different answers. If you can identify the time that it's wrong, you can ask the question again from an LLM and loop through that until it's the one that's not hallucinating. We found that that's an approach that's been working quite well. Yeah, I think it starts with the problem. What's the problem you're trying to solve? Suppose it's a call summary. You'll get a very good answer if you use a very large LLM. Generally, the LLMs perform better when they have a larger number of parameters or weights. For instance, 80 billion llama is better than the 7 billion llama for meta there as well. But if you use the 80 billion one, yes, you'll get a very good answer that compared to the 7 billion one, but it comes with a cost. So the cost is that it's slower, or it could have more token cost there as well. So the aim is to get the LLM that it's good enough, so it answers the question very well, but it's not unnecessarily large, because then you get compute problems and potentially increasing in prices. The other part is, do you really need an LLM to solve the problem? There's some examples where LLM can probably do it. For instance, sentiment classification. LLM's quite good at that. You put in the text, the actual calls, and you ask it to rate it positive, negative, neutral. Another approach is to use deep learning, so you have a typical machine learning classification model at reasonably large scale. The advantage there is that that approach doesn't have a token cost, the compute is much less, but with that one, LLMs can also help. One of the traditional problems with deep learning has been the labeling. So if you want to predict something, you want to predict sentiment or the types of utterances in a call, then you need a very large labeled data set. That was really time consuming, so someone would have to read those and label each of these calls as X, Y, Z. An LLM can assist with that, but with a human looking along to make sure that it is correct, and that can make that approach much faster. So I think it's based on the context, the problem you're trying to solve. Generally, you try to get away with the smallest LLM you can, provided it solves the specific problem that you're looking at. And if you don't need an LLM, there's other approaches, deep learning, topic analysis, and so on. So it really depends where you're looking. Topic analysis has probably been a really important area of NLP for a long time. The reason is you have all these calls or documents and you want to classify them into groups, maybe a whole bunch of research papers, you classify them into chemistry, physics and so on, and maybe a very large number of call transcripts, and trying to classify them into the reasons that the person is calling. Typically that approach has been quite challenging to classify documents in call centres. One of the reasons is the transcripts are very long, and when someone calls, they don't just talk about the one thing they're interested in. They might really be interested in exploring a new product or a new credit card or cancelling their credit card. However, during that conversation, there'll be many different aspects to it. They might be doing verification of identity, they might be chatting to the agent, there might be background noise, or there could be conversations around that aren't specific to the actual thing you're interested in. The approaches previously have struggled a little with that, because when you do topic analysis, it just takes all that text and it groups them together into something common, and the common thing might be can you verify your phone number, for instance? So then a topic is something that's not so useful. So we've looked into approaches that try to get to the key area that we're interested in. A couple of the key ones that we've found is customers are interested in why people are calling. The other one is why people are dissatisfied. Imagine being able to see all the different reasons that people are dissatisfied and be able to group those, measure them through time and see which kinds of intervention initiatives are actually improving and making the dissatisfaction go down, or if there's new emergent themes there as well. To do that, we do some different techniques to previous. I think one of the standard approaches is to convert them, the words, into something called TD-IDF, which just weights up the more important terms in documents, and then use clustering approaches like K-means or LDA. We use a combination of different areas which has improved the performance of the topics. So we use LLMs to try to derive and collapse that large document into something that can be classified much easier. And when it's reduced, what it has the key components that the LLM identifies, which will be useful for the topic. From there, we can use things like word embeddings. So this is when you get a number and you convert it into a series of 700-800 numbers. And then typical approaches for clustering can be used to try to derive those key areas. Dimension reduction we also use clustering techniques similar to the previous ones. But the main advantage though is the cleaning that goes from the initial call. The LLM helps with that cleaning to extract the key areas that we can use. And then approaches such as topic, we use word embeddings and traditional clustering approaches. What we've tried to do also is make that fully automated. One of the challenges in the past, I think, for topic analysis is there's a degree of subjectivity. You might change the number of clusters and you get a different answer. You might do different cleaning rules, maybe part of speech. Some parts of speech are included, some are excluded. That gives quite a different answer to the clusters as well, what they actually appear as. So we've managed to explore and automate that approach, so we hope it gives the best clustering solution each time with very limited intervention there as well. Root cause, the idea is to get a high level view of what are the real reasons people are calling, what are the real reasons they're dissatisfied, and also look at the longer term trends and aggregations of those. We use a combination of approaches, so we've got predictive modelling, we do use LLMs, and we also use the topic analysis approach as discussing earlier. The goal is, what customers really want to understand is why people are calling, what are the key reasons they're calling, why are they dissatisfied, the key reasons, and being able to look through those and see which areas are most which can be addressed, which can be improved, and which are really a product of the agent or the product itself. So we recently worked with a major retailer, and that retailer was interested in understanding what are the reasons for dissatisfaction. Firstly, why were customers calling, but secondly, and probably more importantly, why are they dissatisfied? There's lots of different reasons, but there's often some key reasons, and that the reasons tend to be things that can be addressed and can be improved, and we can identify quite clearly in a simple approach, in a simple visual approach, to see what those areas are. Well, what's the main reason? It's actually deliveries that they're not dissatisfied about. And from the deliveries, we can then dig even further and say, why was that delivery not completed in terms of, and then they can address that and look at initiatives to improve it there. If you had the call transcripts initially, or if you had just pure topics, it would be very hard to identify these, to not only see the reason they're calling, but the reason they're dissatisfied and how to address that, because it goes down to a granular level to see, delivery, yes, it was not delivered, why was it not delivered there as well. And from there, you can start to understand and introduce initiatives to improve. You can also look at things like areas to improve from the agent side there as well. We do find sometimes that it is more operational product issues that it identifies as opposed to agents. The agents, it might be that they can improve how they're addressing the issue, but often there's blockages that the agent can't address, and it's something that's a product of a website, it's a product of a delivery system, it's a product of a refund process, and improving those has the advantage of, well, less calls, better customer experience, more streamlined service there, which has gains throughout. And that's what we're really aimed to try to explore and identify in an easy to use fashion, which uses a lot of sophisticated machine learning, Gen AI and predictive modeling approaches. I think what we wanted to develop here, we call it the customer effort score. So the idea is we want a single value, one number that represents how much friction the customer went through to resolve the call, or how easy and fluid it was for the customer to resolve. When the call is recorded, there's a transcript. It's not just the words in the call, what the customer said and what the agent is. We actually get other data within that as well, which is really important to try to understand how easy, how hard was it for the customer to fix it. Things like how much silence time were they transferred, how much time were they on hold, was it the first time that they've called about the same issue, was it the second time in the same day they called about the same issue, or maybe even the 10th. We can also find out what happens inside the call, so what was the type of friction that they experienced. Perhaps they were unable to self-serve. If a customer can self-serve, they want to go through and complete there and not have to ring because that process broke somewhere along the way. Escalation can be a more serious one, which obviously that's quite a lot of friction. We can identify that as well if a customer asks for a supervisor, or they're clearly not resolving the call at the time on that call and it needs to go through another channel. And also, is the call really complaint dissatisfied type of call? So we have a range of different attributes which we collect together into a single feature, a single value, and that value goes from 0 to 100. 100 means the customer went through a whole lot of effort to try to resolve their issue. 0 means it was working really well, they resolved it, moved on. The idea is really focus on the customer there. So the customer is the one calling with the issue, that they want it resolved quickly, efficiently, without having to call again. And this measures that, and you get a quick, easy way to actually view which customers go through the most issues to resolve it. And you can even combine that with root cause. So suppose there's a lot of friction around certain types of issues, for instance, deliveries. These are the ones that are hardest to resolve, or credit card cancellation, perhaps those are the ones that are hardest to resolve and have the most issues. You can really dig into that to not only uncover the friction, but then look at what areas that's occurring, and that gives you a whole heap of opportunities to try to improve the customer experience and also your internal products operations. Yeah, I think the production governance process for LLMs has some differences to previous. Previously, a machine learning model would go into production. It would be monitored through time. It would have a known cost and a known output there as well. With LLMs, it does introduce challenges. One of them is the token cost. So a token is a small component. It might be the full word. It might be something similar to a syllable of each word. Each of those tokens has a cost depending on which LLM you're using. That's one option. So you pay 0.0001 cents per thousand tokens. That might not sound a lot, but when you're scaling and one call can be 10,000 words and you're getting 10,000 calls per day, the cost can be quite large and also unpredictable if there's very long calls. There's ways to mitigate that. One is to ensure that the LLM you're using is the best one for the task, so it minimizes the cost. There's different options. You can host on a GPU as opposed to doing per token cost. We look at which solution suits the product to try to minimize that for clients. Another area that's quite challenging is around the prompting, the prompt engineering there as well. So to ensure that it's consistent output, it's stable, the prompt itself is quite important. The answer can change through time, but ensuring that prompt to get the right answer and to minimize the output, so each token costs. Additionally, you don't want to ask a question and the output could be somewhere between 1,000 and 3,000 words. You also want to make sure the format of that output is appropriate. We want consistency. So machine learning models are very consistent in the output. They often give a probability, a score or output. The output for these is more challenging because it's a series of words and that can vary in length, it can vary in the way it's expressed. So trying to ensure consistency through prompt engineering and also getting the appropriate LLM is really critical to looking at scaling and pushing these things into production as well. It's really been a real big focus and a learning curve for us as well, but something we're developing quickly and improving. With root cause, what we wanted to do is understand the reasons people are calling, the reasons they're dissatisfied, group them so it's easier to get insights on that. But even with that, it's still required to explore that through Power BI tooling to try to understand what are the key trends, which is growing, which is declining, which is the largest reasons people are calling, which has reduced recently or grown recently. So it needs a fair bit of investigation to understand which area requires the most focus. So we wanted to get the data even closer to the customer. So by looking at things like aggregating the main trends, we can say that product A grew by this, we can say dissatisfaction reason C declined by this, and there's lots of these statistics, and these statistics are important for understanding what are the key areas. Going further with these stats, what we can do is put these into LLMs. So here we're using the LLM to do an executive summary. So based on all the trends in the last month or last 3 months, which is the most important, which areas are potential focus, and what are the main things that have the customer centre has experienced. We can go even further than that. So rather than just stating these are the main trends, we can look at guided recommendations for customers as well. Based on particular reasons that people are unhappy, they might be unhappy with the delivery process, with the credit card application process, the documentation requirements. We can then look at which are the most important, which are the biggest reasons for dissatisfaction, and then give recommendations to the customer automatically via an LLM. We do that via looking at all the reasons people are dissatisfied, aggregating them into certain statistics that can be injected into a prompt, and then asking the LLM, what do you think based on all this context and the prompt engineering that goes into it, could be the 3 most important things that the customer centre could focus on. And then you avoided the need to even investigate. It's still a requirement to investigate, to look at very specific issues, but it gives you a really good starting point to say, look, these are the obvious, big, large hanging fruit that you can really focus on to improve operational agent performance, different hurdles, websites, delivery process. So it's really a time saver and a starting point to really enhance the customer experience.